క్లాసెస్ ఇంటర్ మ్యాథ్స్ లో అన్ని చాప్టర్లు ముచ్చమటలు పట్టించేవే. ఎంతటి ఎక్స్పర్ట్ క్లాస్ చెప్పినా సందేహాలు మిగిలిపోతూనే ఉంటాయి. అందుకే దీనికి సంబంధించిన సమాచారం ఎక్కడ దొరికినా మిస్ కాకూడదన్నది సీనియర్ లెక్చరర్ల సలహా. అందుకే వి అడ్వైజ్ యూ నాట్ టు మిస్ ఈ క్లాసెస్ ఆన్ కేఏబీ టెలివిజన్. ఇక ఈనాటి ఈ క్లాసెస్ విషయానికి వస్తే సీనియర్ ఇంటర్లో కీలకమైన మ్యాథమెటిక్స్ 2A క్లాస్లో ఇవాల్టి సబ్జెక్ట్ ఏమిటో చూద్దామా? ఈరోజు ఈ ఎపిసోడ్లో సీనియర్ ఇంటర్ మ్యాథ్స్ సబ్జెక్ట్ పేపర్ 2Aలోని ప్రాబబిలిటీ టాపిక్స్ గురించి తెలుసుకుందాం. ఈ ప్రాబబిలిటీ టాపిక్ నుండి పేపర్ 2Aలో 22 మార్క్స్కు ప్రశ్నలుంటాయి. మరి అంతటి ప్రాముఖ్యత ఉన్న ఈ టాపిక్ని గత 25 సంవత్సరాలుగా ఇంటర్ ఎంసెట్ ఐఐటిలో అనుభవం ఉన్న ప్రొఫెసర్ ఎంవి చంద్రశేఖర్ గారు వివరిస్తారు. డియర్ స్టూడెంట్స్, నిన్నటి ఎపిసోడ్లో ప్రాబబిలిటీ టాపిక్స్కి సంబంధించి అడిషనల్ థీరం మరియు కండిషనల్ ప్రాబబిలిటీ టాపిక్స్ గురించి తెలుసుకున్నారు కదా. మరి ఈరోజు ఎపిసోడ్లో బేల్స్ థియరం మరియు టోటల్ ప్రాబబిలిటీ థియరం గురించి తెలుసుకుందాం.
Now we will see what we call the total probability theorem. This is very important theorem, and first I will write the statement. The statement is total probability theorem. Now there are events E1, E2, E3, so on, En or n events of sample space. There is an event A. There is an event A. A is an event which occurs with any one of EIs. Okay, then probability of A is equal to sigma I equal 1 to n probability of EI into probability of A given EI. This is the statement of the total probability theorem. I will illustrate one example. You are having the 3 urns or 3 bags are there. Bag 1, bag 2, bag 3. This contains some white balls, 5 white balls, 6 red balls. 6 white balls, 5 red balls. 5 white balls, 4 red balls. Now any one of the bag is chosen and a ball is drawn. What is the probability of the ball being white? Okay, so you want the ball to be white ball to be drawn. White ball can come from bag B1 or from bag B2 or from bag B3. So this particular event of drawing a white ball is happening with conjunction with E1, E2, E3. So this particular probability theorem is to be applied there. Okay, what is the proof of this? We will see now. Proof of this total probability theorem. This is a statement. I am rubbing this off and we will see the proof. What is the proof? Yes, first one. The proof is based upon first 2 concepts. 2 concepts are involved in this proof. These 2 concepts what I am writing, let us not write in our solution. In the solution you need not write these 2 concepts. What are those concepts? First concept is, if A1 and A2 are disjoint, then probability of A1 union A2 is equal to probability of A1 plus probability of A2, if they are disjoint. And the second concept here is E1 intersection E1 union E2, this is the second one. E1 intersection E1 union E2 will give us E1 intersection let us take this as E2 and this as E3. E1 intersection E2 union E1 intersection E3. What does that say? What does this say? This says the intersection is distributive over union. These are the two concepts which are utilized in the proof of the total probability theorem. Yes. Now, the first part here you see, the first part is E1, E2, E3, En are exclusive, exhaustive events as well exclusive events. That means E1 union, E2 union, E3 union, so on En should give us the sample space. So, probability of E1 union, E2 union, E3 union, so on En should give you probability of the sample space. So, I is equal to 1 to N. I is equal to 1 to N, union EI is equal to the entire sample space. Now, you know that E intersection S will give you E again. This is as if the mu and this is this event A. What is A intersection mu? A again. That is a basic set theory concept. So, probability of E intersection S is equal to probability of E. Now, probability of E intersection union I is equal to 1 to N AI is equal to probability of E. So, the probability of E is equal to sigma I equal 1 to N probability of AI into probability of E given AI. That concludes the theorem statement. One question based upon the total probability theorem. Total probability theorem, which we have just seen, one question here. This question was asked in May 2011 as well as March 2011 for 7 marks. Okay, the question is very simple and it is a direct application of what we call the total probability theorem. Yes, a bag B1 contains 4 white, 2 black balls. Bag B2 contains 3 white and 4 black balls. Okay, a bag is drawn, a bag is not drawn, rather bag will be selected. Bag is chosen at random and a ball is drawn. Find the probability that the ball so drawn is white. Okay, this is the question. Now check what they are talking about. This is a bag, 2 bags are available to us. From the 2 bags, randomly 1 bag is selected. Out of that bag, again a ball is drawn and you want to find the probability such that the ball so drawn is white. Again, the question again in nutshell, 2 bags, different compositions of black and white balls, and a ball is, first a bag is selected, and after the selection of bag, a ball is drawn, you want the ball to be